Question number 4 on your stats probability review sheet is dealing with a spinner, and the question says, assuming all regions are equal, so class, we know this circular spinner is divided up into 8 equal regions, so they all have the same probability of being landed on. Use the spinner to answer the following questions. So question number 1, I'm going to scroll down and we'll use the spinner that I made a copy of over on the right hand side. So we always have a spinner in front of us. What is the probability of landing on 4? Well, if you take a look at this, how many 4s are in our spinner? We've got 1, 2, 3 4s. That means 3 things make us happy out of a total number of spaces of 8 spaces. And if we go ahead and divide that out, 3 divided by 8 is 0.375, which is 37.5%. The next one, what is the probability of spinning a number less than 3? Well, let's count. I'm going to start from this space right here, just past the 12 o'clock, if this was a clock. So how many spaces are less than 3? There's 1. That one's not it. 2, 3. We have 3 spaces that are less than 3 out of a total of 8 spaces. That's the same fraction, or same decimal we just had, and then of course the same percent that we just had. 3 spaces out of 8. 3 spaces make us happy out of a total of 8 spaces. Next one, what is the probability of spinner landing on a gray 4? Alright, how many gray 4s do we have? That's white, white. There's a gray 4. So we've got 1 gray 4 out of a total of 8 spaces. Oh, you know, I see I read that wrong now. Let's take a look at that. Almost got that wrong. What's the probability of spinning the spinner landing on, what is the probability of the spinner landing on gray or a 4? Gray or a 4. That means either one of those spaces make us happy. Well, if we look at this, we've got 4 gray spaces. So we've got the probability of landing on gray plus the probability of landing on 4. So gray spaces, there are 4. And 4 spaces with 4 in them, 1, 2, 3, there's 3. But we have some spaces that are gray and 4. So those are our overlaps. So we want to get rid of those. So we've got 1 space that's gray and a 4. So 4 plus 3 minus 1 equals 6. So our fraction is 6 over 8. And that is 0.75, or exactly 75%. Let's take a look. Okay, now we're spinning the spinner twice. Remember, class, again, if it doesn't specify how often you are spinning the spinner or how many times, you can assume we're spinning 1 time. But now we get down to the next question, and now it says if spun twice, what is the probability of spinning a 2 both times? Let's scroll up where I can see the next spinner. A 2 both times. Well, if we want things to happen twice in a row, we're going to take the probability of landing on 2 and we're going to multiply it by the probability of landing on 2. These are independent events because a spinner does not remember what happened before. It doesn't change the outcome of the next spin. So the probability of landing on 2, we've got 1, 2. We've got 2 spaces that have a 2 in them out of a total of 8. The next probability will be exactly the same because they're independent, and we multiply those together. 2 times 2 is 4. 8 times 8 is 64. So our fraction is 4 over 64. And that is 0.063, or 6.3%. Remember, when you multiply the decimal by 100, it moves the decimal 2 places to the right. So this is not 63%, it is 6.3%. And then the last one, if spun 3 times now, what is the probability of landing on an even number all 3 times? Well, again, these are independent events. They do not affect each other. That means all we have to do is find the probability of landing on an even number. and multiply it by itself 3 times for the 3 different spins. So how many even numbers do we have? 1, 2, 3, 4, 5. So you have 5 even numbers out of 8 times, there's our second spin, 5 times 8. Here's our third spin, 5 times 8. Our only issue here is getting really big numbers. 5 times 5 times 5 is 125. 8 times 8 times 8 is 512. Let's write that a little bit clearer. And so our fraction is 125 out of 512. That's going to be 0.244 or 24.4%. All right, the last question says, when spinning the spinner multiple times, are the events dependent or independent? Explain why. I would expect this explanation to say, well, I know spinning a spinner creates independent events because the outcome of the second event is not affected by the outcome of the first event. You could also say because the spinner has no memory and you are not removing numbers as you spin the spinner. So there's lots of ways to describe that. Just make sure you're giving some description that's saying it's because we know that the outcome of the second event is not affected by the outcome of the first event. And that should be the end of question number 4.